Hello, Precalculus student. This video is for Chapter 3.1 Complex Number, Part 2. We are looking at dividing complex number and also doing exponent on complex number. Now, to do square root or other roots of complex number, you will have to wait until you know trigonometry. So, for some reason, doing square root of complex number is more complex than you think. Okay, multiply, add, and divide is easy. So divide. So how do I divide? The idea is this is not a valid form of a complex number. A complex number has to be always a plus bi. So you are not allowed to have just like fraction that will have a number in the top, a number in the bottom. Just like radical, you're not supposed to have I in the denominator. It has to be something like that. Has to be just one I, cannot have I in the top and bottom. So we need to get rid of this. So the idea would be if I multiply I in the top and bottom, so I'm doing equivalent fraction. So I and I would be I squared become a not a complex number, right? So it would become 3I squared. Remember I squared is -1. So I can get rid of the I no more. And then this would just need to distribute. Okay, don't just multiply the last number. So it becomes 6I minus 5I squared. Simplify it. Whenever we see I squared, we replace by -1, so it will be -3. So 6I is 6I. So, but then 5 times -5 times -1 will be plus I, plus 5. So switch them around so that the real go first. So it'll be 5 over, well, -5 over 3. That's the real part. Minus 6I over 3. That's the imaginary part. So you can simplify it further as -5 over 3 minus 2I. And it's a complex number. A real minus 2 real I. Okay, so if there is only I in the denominator, you just do I and I. But if you have two terms, like a plus bi in the denominator, we will have to use the complex conjugate property. So because we want these to be free of I, and last time we talked about if I multiply the complex conjugate, I will have something after I multiply, it would be all real. So in order to change, not to change this kind of fraction, we multiply something top and bottom the same. So the bottom would be a complex conjugate multiplication. It will be 4 squared minus 3I whole thing square, right? So no I left over because I squared become -1. The top you have to do FOIL. So 4 times 6 times 4, 24, 6 times 3 plus 18I, 5I times 4 plus 20I, 5I times 3I plus 15I squared. Okay, so simplify a little further. So the bottom would be 4 plus 9 because the minus I squared become plus 9. And at the top would be, this become minus 15, right? Because I squared is -1. 24 minus 15 is 9. 18I plus 20I is 38I. So this is 13, so I split it up 9 over 13 plus 38 over 13I. So in case you can cancel, you cannot cancel, you can have a fraction. They're still real number. So but it is an a plus bi. What about simplify 3 plus square root of -20I? Whenever we see -20, we know that, oh, this has to split up as I. 3 plus square root of 20 times square root of -1, and this would be I, right? Divided by 4. So square root of 20 can be simplified as 2 root 5, right? Because it's 5 times 4, and then an I. So this terms is very complex as a irrational part, as a real part, and a I, and over 4. And you split it into a real number. 3 over 4 is the real number part, and the other one would be 2 root 5 over 4 I. 2 and 4 you can simplify further still. You go plus root 5 over 2 I, like that. If you have a fraction where the top is 1, but then the denominator is two things, you just do it as if you can, we say rationalize the denominator by eliminating I in the denominator. So what's the complex conjugate? It's 4 minus I. So top and bottom 4 minus I. So that would equal to 4 minus I in the top, nothing to multiply because it's 1. But the bottom is conjugate. So conjugate means 4 square minus I square. I squared is -1, so it becomes 16 plus 1 and 4 minus I. So split it into 2, it will be 4 over 17 minus 1 over 17I. And that is a complex number with nothing in the denominator. Okay. Exponent of complex number. When we want to do exponent, so let's look at the only thing we know is I, right? But I squared is -1. So I cube is, here I write I cube is -I. Why? Because you can write it by property of exponent. I cube is I squared times 1 more I, right? I squared is -1, so it's -1 times I. So that's why it's equal to -I. But what about I4? I4 times is I squared times I squared, right? Because I have 1, 2, 3, 4 multiplied together. Every I squared is -1. Another at -1 times -1 is just 1. So I4 is very good because if you multiply I to the power 4, it's just 1. So if I have some exponent to do for like I to the power 29, what I want to do is I wanted to write it in terms of a power that is a multiple of 4. What is the closest multiple of 4 of 29? That's 28, right? Because that would be I4 7 times I1, right? Because 28 plus 1 is 29. This is 1 time. I28 is I to the power 4 7 times. And this is 1 7 times is just 1, right? Times I. So ultimately I have 1 times I, that's equal to I. It's just a complex number. Okay. Anything that results of an operation is a complex number. What about I34? So what is the closest number that is multiple of 34? Oh, 32, right? So this is the multiple of 4 times what is the leftover square? What is I32? We know it's 1. Anything that is multiple of 4 exponent is 1. I square is -1. So 1 times -1 is -1, which is also a real number or in a complex plane. The last few questions is about plugging in a complex number into a function. Now, this must be a function that is in the complex plane. Usually when we are looking at, like in chapter 1, when we're looking at regular function, they are function in a real number plane. So that's why when we do domain, we only allow real number. But if this function is defined in a complex plane, I can plug in a complex number. So you just do 5. X is 3 plus 2i. And then square it. You have to do FOIL to square it. 4, 3 plus 2i, and then a plus 1. So how do I do 3 plus 2i? It would be 3 plus 2i times 3 plus 2i, right? So you have to do FOIL plus, let's say, 12 plus 8i plus 1. There is just a lot of terms after this. So 5 multiplied by 9 plus 6i plus 6i plus 4. Don't remember the square, so don't forget the square. 4i square plus, let's combine 13 plus 8i, right? And then I have to distribute the 5 into it. 45 plus, let's just combine this 12. 12 times 5 is 60, 60i plus 20i square plus 13 plus 8i. Now all the I can combine, right? So I have 60 and 8, so 68i. So I say 68i. What about the other? What about I square? I square is a minus 20. 45 minus 20 plus 13 plus 48i, and so this become 25 plus 13, 25 plus 13, 38 plus 68i. So So that's how we do it. So it's just a matter of doing some arithmetic of I. Let's plug in a function x plus I, x minus x plus 1, x minus 4, but plug in negative I. So that would equal to negative I plus 1 over negative I minus 4. So what's the complex conjugate of this one? Oh, the real keep the same. The conjugate, the I part, change sign, right? So negative 4 plus I is this conjugate times. Oh, I should say. So you should do it this way. Times negative 4 plus I. So it's just a matter of FOILing the top and then multiplying the conjugate at the bottom. The conjugate would be negative 4 squared, which is 16, I squared minus I squared, so it would become plus 1. The top would be, okay, negative I times negative 4, it would be 4I. Negative I times plus I would be minus I squared, 1 minus 4, 1 plus I. So the bottom is 17. The top would be 4I plus I is 5I. And then this is 1, negative 4, negative 3 plus 5I, right? So split it is negative 3 over 17 plus 5 over 17I. So just do calculation, do more calculation. The last part is the application, like to actually explain why we're doing all this complex number, is because during solving equation, sometimes we run into a situation where we will need to solve something where x squared is equal to a negative number. So we'll just do some solving quadratic equation review in the last part. So I'm going to do in the next video, I'll do part 3 of 3.1, which is solve quadratic equation. Some of them will have real answer, no complex number. Some of them will involve complex number. In the old day, we will say no solution. Now, if we solve it in the complex plane, we will have solution. So part 3 of 3.1.